Install the software Mixenv, extract the compressed file, run the installation program, follow these steps in order. Name and company can be set by yourself. The installation directory can be set by yourself. Mixenv installation completed. Open this database to install the database. Install with all default options selected. Proceed directly to the next step of the installation. Connect the 24 volts power supply and the network cable. Right-click to open the network and internet settings. Advanced network settings, change adapter options. Replug the network cable to confirm the port. Right-click the correct network port. Select protocol version 4. Double-click to manually set the IP address to 192.6.6.10 range 10 to 55. The X value in can be set within the range of 10 to 55. It just needs to be different from the Mixenv address. Observe and check the operating status of the board's indicator lights. The PWR light is constantly on, the ALM light is off and the run light is flashing. If the operation is normal, open Mixenv. Click on the communication method and confirm the IP is 192.6.6.6. Click Communication Test. Test the ping value to check the network connection status. If normal, proceed to the next step. If communication fails, check the network cable connection status. Follow the hardware manual step by step. Correctly connect the galvanometer, laser, each axis, and limit switches, etc. Ensure the wiring is correct before proceeding to the next step. In Mixenv, click on Motor Status. If it doesn't display, click View and then one-click Restore. Confirm that the platform is in a state where it is not in contact with the limit sensors. Manually or move the platform to trigger the limit sensor. Observe whether each corresponding limit sensor is working properly. Click on Motor, then Motor Settings. According to the corresponding axis number, select the axis control mode. Correspondingly select the pulse direction. For the bus, select Co-CSB mode. For analog, select PID closed loop control. Here, we use the pulse direction mode plus forward direction to demonstrate subsequent operations. If the machine axis uses a linear motor, manually move the platform and check if the value at the #1 position window changes. Whether the numerical value increases or decreases according to the direction of movement. If it does not match, you need to invert the axis control mode to pulse direction mode plus negative direction. Set the control mode for each axis in sequence and confirm whether it is correct. Set the subdivision ratio according to the motor manual. During the tuning process, the recommended acceleration time is 50, target speed is 100, and return to zero speed is 15. Later, the running speed can be increased as needed within the software. The settings depend on the requirements. If the speed is set to high, the accuracy will be affected and an offset will occur. If the speed is set low, the accuracy is high, but the speed is slow. It can be adjusted later. If the driver alarm is in a normal state, if the status bar lights up, you need to reverse the operation. To reverse the encoder, you need to move the platform and observe the numerical feedback. If the movement is consistent with the numerical logic, then there is no need to reverse the encoder. If it does not match, you need to check this box to perform the reverse operation. Check the virtual encoder if the driver does not support encoder feedback. For example, in bus mode, mark the PSO walking point spacing. Then you must connect the encoder feedback and cannot select it. After completing the settings, click Apply to save. Click Jog and select the corresponding axis control number. Click Stop or Activate Enable to activate the motor enable. Set the step size to 1000 counts. Click the forward jog and observe the platform movement direction, whether it matches the encoder feedback value. If the movement amplitude is too large, reduce the value for testing. If sending 1000 counts forward jog, the platform moves in the positive direction, and the encoder feedback is -1000 counts, then you need to reverse the encoder. If sending a forward jog of 1000 counts, the encoder feedback value is 1000 counts, but the platform moves in the negative direction, Then invert the axis control mode to pulse direction mode. Debug each axis number in sequence until they are in normal condition. Click on Laser and select General Laser Control. Select Channel 1 according to the connection of the control card. Generally, Channel 2 is only used in the case of dual lasers. Confirm the laser type. Here, take nanoseconds as an example. Prepare a piece of black photographic paper under the platform galvanometer. Click Turn Laser on or off. Observe whether the light output is normal. If there is no light output, you need to check the laser wiring and status whether the galvanometer is reset. Advanced PWM control is used for PSO, which will not be covered in this debugging session. Click Laser, select MOPA Fiber Laser Control. According to the connection of the control card, select the corresponding laser channel 1 or 2. Set the frequency to 10 and the duty cycle to 50 as a reference. Prepare a piece of black photographic paper. Check for light output. Adjust according to the actual light output situation. Set the power to 20% and the Q pulse width to 5ns. Click One-Click Settings to save all configuration contents. At this point, the master oscillator is on. Click to turn on the power amplifier. Observe whether the light output on the black photographic paper is normal. Click Galvanometer, select Galvanometer to enter the galvanometer settings interface. Confirm the galvanometer protocol defaults to XI to 100. If you need to set cell to 100, you need to contact after sales support to provide a patch file. Set the side length to 8, frequency to 50, and power to 60. Check the box to turn on the laser. Click Direction Test to check if the galvanometer swings normally. If it does not swing normally, check whether the galvanometer wiring is correct. Right-click to extract this compressed package to this folder. Open the software installation package. Click Install. Set the installation path to the C drive. Follow these steps in order. After the installation is complete, extract the update package to the installation directory, and replace duplicate files. LaserLS installation completed. The software is running normally. Enter the user management interface. Select Administrator. The password is 1. Technician. The password is 2. Operator. The password is 3. You can change the password as needed. The software motor parameters are not properly debugged. Then click No. Do not perform the homing operation. For machines without a Z-axis, click Process Parameter Settings and check Do Not Use Z-axis. Additionally, some commonly used functional parameters can be checked here. Select the functions here according to your needs. Restart the software. The following demonstration content is for a machine with a Z-axis. Click Device Parameters and select Motor. The password for this type within the software is generally Psi1 to 3. Set the X, Y, Z coordinate axis subdivisions according to the motor manual. For safety reasons, it is recommended to set the Z-axis speed to around 20. Set the running speed, manual speed, and homing speed according to the actual situation. Uncheck continuous movement on the right side of the software. Use the mouse to click the arrows for jog movement. Observe whether the axis movement direction is consistent. If it does not match, you need to reverse the jog direction setting. After completing the settings, click Save. Click Device Parameters and select Platform. Enter the platform parameter settings. Click the arrow buttons on the software interface. Move the platform to a position close to the upper left limit. Approach the limit sensor and record the current position. Move the platform to the lower right near the sensor position. Do not touch the sensor and record the current position. This is to obtain the platform processing range, or set a reasonable processing range according to the galvanometer used. After completion, save the settings. When installing the camera and laser, it is recommended to keep the focus position consistent. Click on Camera, then select the camera type. Select the corresponding camera according to the actual situation. How to determine the camera resolution? Need to close LaserLS, then open the camera software. Double-click to open the camera. Then press the play button. The camera is now open, and its resolution is displayed on the right side of the software. Record the resolution and input it into the software settings. Close the camera software and restart LaserLS. Enter the correct camera resolution and click Save, and restart the LaserLS software again. Place a piece of black photographic paper, turn on the laser and move the focal length up and down. When the laser shows the minimum spot size, record the PZ value. Click CNC and select Focus Measurement, set according to the actual height of the Z-axis. Here, the default PZ50 is used as an example to start the test. The step length is 1 mm and the automatically calculated number of tests is 10. Set the X plus step length to 6.4 mm and the Y plus test line length to 4.8 mm. Select the test pattern as a square. Prepare a piece of black photographic paper and place it under the galvanometer. Execute the marking and observe the marked squares. Find the square with the best marking result. If the 7th square is okay, then select the 7th test point and calculate the appropriate focal length as 56 mm, and click Synchronize to camera focus. The camera's clear position and the laser's focal point are at the same location. This is done by moving the camera to fix the sheet metal part. Click Device Parameters and select Galvanometer. Prepare a piece of black photographic paper and place it under the galvanometer. Click Test Direction and observe whether the XY directions are consistent. If it doesn't match, select the coordinate axis that matches the actual marking direction to make adjustments. After adjustment, verify the direction again to ensure it is correct. Place a physical object beneath the camera and adjust its position. Observe whether the on-screen imaging corresponds accurately to the actual movement of the object. If discrepancies are found, adjust the direction, rotation, and mirror settings in this section. Open the camera interface. Configure the parameters as required. Engrave a crosshair pattern at the center of the camera view. Move one end of the crosshair to one edge of the camera's field of view. Set this as the 0 point. Move the vertex to the opposite edge of the camera's field of view. Observe the value displayed at the bottom, 3.26. Enter the password, Psi123. Calculate the correction factor by dividing the image width 1280 by 3.26, resulting in approximately 390 to 0.638. If the longitudinal test option is checked, use 1024 for the calculation. Save the settings. Check the Move on Left Click option. Left click on a target position with the mouse. Observe whether the camera center moves to the clicked position. This verifies whether the camera factor parameter has been set correctly. Open the camera interface in the equipment. Set the parameters according to the configuration shown in the video. Click Verify Center. Move one end of the crosshair to the camera center. Set this vertex as the 0 point. Move the other end of the crosshair to the camera center. Observe the PX parameter at the bottom, which should read 10.244. Open the galvanometer interface. Enter the password, Psi123. Enter the theoretical value, 10. Enter the actual value, 10.244. Click Calculate. The correction factor obtained should be 707 bits or mm. Then save the settings. Move to a different position and verify the center again. Locate one end and set it as the 0 point. Move to the other end and check whether the actual value matches the theoretical value. Open the camera platform in the device. Set the parameters as shown in the video. Select the crosshair pattern and click Start. Click to move major camera 1. Locate the center position of the crosshair. Enter the password, Psi1 to 3. Click Set Current Position in the Offset Recognition settings. Then save the configuration. Move to a different position and verify the center again. Ensure the previous settings are accurate. Check the box for Set 0 point with camera reference. Set the 0 point. Move to the 0 point. Click on CNC Control and select Galvanometer Calibration. Choose the initial file as the correction file. Set the array to 5x5, region size to 30 mm and engraving diameter to 0.6 mm. Select the circular pattern. And set the maximum deviation to 0.01 mm. Then click Execute. Click Generate Correction File. Apply the newly generated correction file. Double-click the 0-point coordinates. Open the tool panel and check the Move on left-click option. Here, you can adjust the camera recognition area. Move the position until no circles appear within the camera view. Then set the 0 point and move to the 0 point. Continue by clicking Execute. If errors persist, proceed to generate a correction file again. Apply the newly generated correction file. Double-click the 0 point again. Move the position until no circles appear within the camera view. Then set the 0 point and move to the 0 point. Continue clicking Execute. If errors persist, proceed to generate a correction file again. Apply the newly generated correction file. Double-click the 0 point again. Move the position until no circles appear within the camera view. Then set the 0 point and move to the 0 point. Continue clicking Execute. This calibration session has been completed successfully. There is no need to click Generate Correction File or Apply New Correction File. Next, select a higher density array, and repeat the procedure described above to perform a more precise galvanometer calibration. For ongoing maintenance, it is recommended to calibrate the galvanometer every 2 weeks.
点击数控，选择 I/O 状态，监测各状态是否正常。I/O 状态绿色表示无信号，红色表示有信号。准备一张黑色相纸置于正镜下方，画房形加圆形图案作为演示。选择分块，根据正镜范围参数设置正镜块的宽度和高度，一般推荐小于正镜最大范围以达到最佳效果。点击开始进行刻画，检查刻画结果是否有拼接不齐或者图形变形等不佳现象。如结果良好，则可进行加工。
The following demonstration is for vision positioning, PCB board cutting, and depaneling processing. Prepare the processing materials and corresponding drawings. Use the mark points prepared in the drawing for positioning. After the positioning results are confirmed to be accurate, proceed with processing. Check the processing results. Select the graphic, right-click and choose Set 0 point to the center of the selected diagonal. Select the graphic again, click Identify by area size to identify another mark point, and select red to set it as the positioning layer. Select the graphic and add the actual coordinates. Select another mark point graphic and add the actual coordinates again. Click on the camera interface. Identify this mark point. After clicking, identify another mark point. Click Apply. Click the first to return to the first mark point. Click Auto Position to confirm whether the mark points were correctly identified from the previous operation. Click on the CAD interface. Click to open the Processing Parameter interface. Set the required processing parameters according to the machine. When processing, you need to check Process All. Click Start Processing. The set mark points will be automatically recognized within the camera. After recognition, processing begins. Processing completed.